Alright, so our question is find the charge on outer surface of the shell, which is find x, and this is our system. Q2 is outside, Q1 is inside the shell with from a distance from the center, even though it does not look like a center, but it's the center. And then the shell is grounded, and yes, this is a conductor, obviously, otherwise the charges won't move. Also, this question is pretty hard, even harder than advanced level, so let's try to solve it. Now, firstly, we know minus q1 charge will come on the inner surface of the shell, obviously to make field equal to 0 inside the conductor, which is between the outer and inner surface. Q1 will arrange in minus q1 will arrange in such a way that field becomes 0 there, and this will be non-uniform. As this is non-uniform, this is such that field outside is going to be 0. As field outside is 0, we can say V equal to minus E dot TR. This is equal to 0. Then potential difference at infinity and here is 0, meaning here is V equal to 0 due to this only. Now, better way to solve it and understand and explain it to y'all is make two different systems, that is using superposition. But I explained this part because later on I won't go into this much details, because obviously if I keep repeating this point, it'll take time. Now, dividing it in two sections, that is, first system is going to be just the sphere with q1 inside from the center, and this distance is a, and minus q1 here. Now due to this v is 0, we discussed it earlier obviously. Now second system is this, and yes, this is grounded, and in the second system, alright, my drawing needs some improvements. q1, q2, from the center this is b distance, and here is charge x, and obviously this is grounded. Now we have to overlap these two such that potential here is 0. Now here is 0, we have to just take care of this. Now what should be x? Look, in this particular system, x will arrange such that firstly it will be non-uniform because of the charge q2 in its affinity. It will arrange in such a way that E equal to 0 inside, because obviously it doesn't want field in a conductor, right? So if in between the walls field is 0, obviously inside will also be 0. And a shortcut here, if there is no charge inside the shell, we can fill it and assume it to be solid metal sphere, which is a shot put ball. And if field is 0 here, the potential at here, let's say this is point C and this is point B, then V at B equal to V at C. How? Because there is no field from here to here, so potential difference will be 0 from the earlier formula I wrote right here. That is going to be 0, so VC equal to VB. Thus we can find V at C. V at C is going to, and the reason should be clear why are we finding V at C, because it's easier than V at B. I mean, V at B directly is almost impossible to calculate using our current knowledge. So V at C is going to be, due to x, is going to be kx by r. Oh, here I didn't mention r in the question, my bad. I will mention now. R. Alright, that's the question. And now we at C we are finding this due to the shell. It's this. So sort of superpositioning. We just took x, then found, then using q2 we found at the center that's going to be plus kq2 by, oh, the distance here is b. Alright, that's v at c. Now v at c we found is this. Now that's equal to v at b. vb equal to this. Now this should be 0 because obviously it's grounded. So thus we get x as q2r by b. Oh sorry, q2b by r there and minus sign there. So this is our x. Yeah, that's it. We found out x. This, and all. So we basically, to recap, we divided into two systems. This is system 1, this is system 2. If we overlap these, we'll get this obviously, because there's q2, q2, q1, q1, the shell with charge minus q on x. Here is minus q, there is x. Now just here v0, reason should be pretty damn clear because I explained it 2 times. V here, v at b is this, which should be equal to 0 because this is grounded just like me, down to earth, and we get x as this q2b by r. And that's it. But the main part was we took x non-uniform, still we wrote this because the distance from here is constant. So if we accumulate x at same point, it is going to give the same potential. Thus we found out potential directly, kx by r and kq2 by b. That's it. Thanks for watching. I'll try another question of sort of the same concept.